Thank you. I've prepared 24 slides, and if we do it in the pace we had yesterday in the Ignite talk, we will be through in 6 minutes, which means you have plenty of time for questions and stuff. Of course, I won't do it in 6 minutes. I'll try to provide some context about me, about the company I'm working for, and about the tool I want to introduce you to, the Checkmk re-implementation the company I'm working for did. A question to the audience: is there someone who did not have to deal with Checkmk in the, let's say, last 12 months? Okay, that's a few, not many. Is there anyone who is not aware of how Nagios-style monitoring systems call active checks and work with the data that is returned? Okay, that's 3 people. So that's enough people to explain it shortly. Active checks are scheduled by the monitoring core, and they are executed usually once per minute for each host that's in monitoring. For each active check, a process is started. This process runs the active check, and in the end, the exit code of the process is evaluated, and the standard output of the check can provide further data that can be used for metrics in monitoring or in human readable information. So when we are dealing with active checks, we have to make sure that these checks are spawned very fast, execute very fast, and if possible consume the least memory possible, because for each active check a process is spawned. So that's a short explanation of the thing I'm talking about. A bit on me. I'm neither a marketing guy nor a developer. I started as tech journalist. Some of you might be puzzled. You might have heard my name before, even if you don't have to do with Checkmk. That might be because I've written lots of stuff for Data Becker, Heise and others, and I'm still a little bit involved in CT magazine. So from time to time you might see my name there. I'm currently a full-time employee at Checkmk, and since I'm someone who knows how to write things, my main job is working on the official user guide for Checkmk and doing other product communication stuff. This means I have early access to new features or to planned features, because I'm usually the one who's asked, can this be documented in a way people will understand it, and I'm doing product communication in general. Things like when my product managers want to decide unpopular things that will embarrass many users, I'm often the one who has to communicate that this decision is in fact really good for them and for us as a company. These are really nice challenges I'm willing to take, and I'm here now to convince you to try out our new Checkmk. We called it Checkmk version 2. At the point we found out we cannot get it fully compatible, but more details on that later. And I hope I can help you taking the decision which host to migrate soon. There is one big point, one big reward when you do this. That's also later. Which hosts you will migrate at some later point in time, and which hosts you will probably never migrate to the new check. So, where did we start? we had this old check HTTP. Okay. We had this old check HTTP. It's a check provided by monitoringplugins.org, and at Checkmk, most development is customer driven. So if a customer complains about something not working, we are trying to make it work, sometimes as a paid feature, and if enough customers complain about something not working, or let's get a positive let's get a positive wording. If they would be happy for a new feature and stuff, we take care about this. And check HTTP was something that generated lots of interest for small annoyances and missing features from our customers. For example, a big problem is that priority handling of command line arguments is a bit opaque. So if you specify command line arguments, that first command line arguments to check for a certain HTTP return code, or a certain string to be found in content, and then specified command line options for checking certificate lifetime. The command line options for certificate lifetime will surely get ignored without any error hinting on this. This means, if you are aware of this problem, you have to do more than one call to check more than one thing. So if you want to check the return value and the response time, that can be done in one call. But if you want to check certificate lifetime, remaining certificate lifetime, you have to do another call. This means double calls. There are other problems. There are problems with chunked contents, like when you are searching for strings and a string accidentally is on the border of chunks, it won't get found. You have a limited range of login options. It's hard work adding cookies and stuff. So, and SSL handling in general needed improvement. For SSL handling, the classic check HTTP has a very, let's say, relaxed approach to validating a certificate chain and stuff. But users expected an HTTP check to behave like a browser. So if SSL certificate chain does not validate, it should not progress any further. That was our starting point. Then there was the question, should we have worked on the existing check HTTP? We considered this, but this would have led to very many pull requests and thus probably overwhelming the existing maintainers of the check. It would have introduced new dependencies. The monitoring plugins, for good reasons, try to keep the number of dependency relatively low, to keep all those monitoring plugins extremely portable. And what here it gets really hard, changes of how CLI options are interpreted surely would have broken existing configurations. So even bug compatibility is an issue. It's this was to be expected since this old check HTTP. How old is it? I think at least 17 years, maybe older. Is here someone who can name a date? How long this check dates back? I'm not sure, but 16 or 7 years at least. So our conclusion: it would have need a lot of time. It would have need lots of if-defs to effectively make dependencies as build time dependencies, and diplomacy regarding diplomacy in communication with the maintainers, and diplomacy in communication with the users, to introduce new paradigms and, of course, to break existing configurations. So then our decision was, let us make it new. Let us completely re-implement this check. At that point in the talk, I want to emphasize we don't want to offend the people who are maintaining the monitoring plugins. They are really doing a great work. They are maintaining a great and comprehensive collection of plugins, and even although having its problems, the existing check HTTP will surely remain relevant as a relatively quick to use thing for the future. So I guess there are people here from the monitoring plugins.org project. Do you want to out yourself? So anyway, you're doing a great job, and maybe we should applaud them if they are here. So the next decision we had to take was which language to use. In our company, we are working in 3 languages: C and C++ for old, fast stuff, Python for the maintainable stuff, and Rust for the new fast stuff that we hope will be maintainable as well. We tried to write down the positives and the negatives of all those possibilities. Sure, using C, C++ would have allowed for integration, for adding it to the monitoring plugins.org collection, but on the other hand, it would be harder to maintain. Python would have given us the possibility to move this active check to a Checkmk special agent, but that Checkmk special agent is very different from the classic Nagios active check style call, which would have meant even a harder migration, a worse performance, and Checkmk only. Rust, in the end, it's easier to debug, extend, and maintain. The check itself as a standalone binary using the Nagios exit codes and stuff, easier to migrate, and it's compatible to other monitoring software like Isinga, Zabbix, Nagios, Nemon. There might be others as well, and the performance should be quite well. But integration a bit less optimal than the Python solution. So now I want to ask you, who of you would have used C or C++? Hands up. No one? It's one, so a bit. Who would have used Python? A few. Who would have gone the Rust way? Okay, that's a bit more. Who does not have an opinion on this? Okay. Who did not raise their hand on one of those 4 options? Anyway, for us, Rust made the race, and of course, or not so, of course, because we maintain some closed source components, but in this case, we considered it as that essential that we want to give back to the to this family that has its roots in Nagios, and we open sourced it. So, and now let's get practical. So that was the theory and the background. Building a Rust binary is quite easy because the whole Rust tool chain is mostly self-containing. It's basically trusting some shell script you get from the Rust setup server without looking at it. And then you have the Rust environment installed. Then you clone the Checkmk sources. And you might or might not check out the 2.3 branch. 2.3 is our current stable branch. There's lots of development going on with this check. We are considering the 2.3 features as stable, and they don't get many changes in our development branch. So if you are brave, omit this checking out the 2.3 branch and directly go to the build. Don't forget to add the release flag, because if you're omitting the release flag, you're expected to pass very detailed debug command line parameters when running the check. That's a bit annoying, so I really recommend go with the release flag. Building takes like 2 or 3 minutes. It's not even enough for a coffee. And then just run it in the simplest way possible. The simplest way possible is running it with a sole command line parameter for an URL. The check itself will determine if it's HTTP or HTTPS, will determine the host name and will run the check on basically certificate validity. So the full certificate chain has to validate as you're running it in a browser. Yes, that's the easiest way. Do this for the first test. And in the end, one note, you see here the binary, the target, the build binary is called check.http. Because at some time in the distant past, we were convinced that we would make this check a full drop-in replacement for check.http. It does not work. We will break too many things. So when delivering the binary with Checkmk, the binary is called check.http version 2. And that's what I suggest for deploying it either to user bin or in your monitoring plugin monitoring plugins directory, wherever it's easy to call it. Now, the biggest advantage surely is you can now with check.http v2 you can check TLS version certificate lifetime here, 15 days and 7 days, 15 days for warning, 7 days for critical, the status code, and implicitly it will also check that the server name include for docs.checkmk.com is correctly contained in the certificate. So now imagine you have 10,000 hosts in monitoring. For each host you do this twice per minute. With the old check, now you do it instead of 20,000 times per minute, you do it just 10,000 times per minute, because you don't have to spawn separate processes for certificate validation and status code check. If you're unsure how to build the command line, it's quite quick. You just install Checkmk. Installing Checkmk is like 3 minutes because everything is contained in the package. then in the setup, you search for check HTTP, and you make sure not to use the deprecated service, because the deprecated service is our configuration for the classic check HTTP. You need check HTTP web service. Then you create a rule, click through the rule, which things you want to check, and in the end, you let you show the command line. You just go to a host which you have just associated with this rule for the check, and copy and paste the command line. So that's often easier than tinkering with the command line arguments. Tinkering with the command line argument works quite well, because you will get an error if command line arguments are incompatible. You won't run in the situation that when command line arguments are incompatible, some are just ignored, because this is wrong trust in a check, which should not happen in monitoring. Okay, one more. Are you also the type of person that runs a minimal web server just to check certificates with the old check HTTP? For example, when maintaining a email server, just having this web server for the certificates, minimal web server, but my colleagues also developed Checkcert. This one is very similar to Check HTTP version 2. It also has the Rust sources in a parallel subdirectory to check HTTP. It builds the same way, and it connects to any SSL-enabled service. So you don't have to call it on an HTTP endpoint. You just can connect it to, I think 993 is IMAP-S and related stuff. And this Checkcert even provides more detailed checks for server name, includes subchecks, issuer validation. For example, issuer check for a certain issuer can be quite important in some failover situations, where some CDN provider as issuer sometimes should be there and sometimes should not be there. You can add your own CA when working with internal CAs. Checkcert currently also lets you check self-signed certificates, which I'm not so happy with, but we have some customers who called for it. So basically use this when you don't have an HTTP server using a certain certificate, or of course for HTTP when you need more detailed checks than that are possible with Check HTTP version 2. One more detail, when you are working with the Checkmk user interface for those new checks, in both checks you won't get all available command line options available in the user interface. There are reasons for that. For example, these options to pass self-signed certificates are currently only available on the command line. We kind of want to educate and protect our users. So if someone visited the talk yesterday, we tried to move our users to using internal CAs rather than self-signed certificates, it's not possible always. For example, when dealing with some network laser printers, they often come with self-signed certificates you can't get rid of. Yeah, so that's it. Check the command line options by running it with the help options. Check the GUI in Checkmk to combine some general command line and just tinker with it. In the end, you will find out there are many hosts where you really have a quick win by replacing running these two calls of check HTTP for certificate and content or status code, combining it into one and effectively lowering your load to the half for these hosts. Yeah. Yeah, basically that's most. If you have any questions, we have 5 minutes left. In case you want to know something about existing bugs or handling certain problems or how we approached certain annoyances with check HTTP I did not yet mention, or you just have questions regarding the roadmap, ask them now, please. Do we have the cube?
All right, thank you, Mattias. Thank you for showing us the process of implementing your new check HTTP. And if there are any questions in the audience, please feel free to ask them.
Okay, first of all, thank you for your job. It looks really promising, so definitely I will try to find out. But I have a question. I saw that one of the options was the status code. You can provide what is the expected status code, but it is possible to provide multiple status codes. For example, okay, 200 is definitely okay, but for example, we have sometimes the cases when 302 is also acceptable for us. So basically, how to handle such situations with the new?
For redirects, the default is to follow the redirect to a certain level of redirects you can specify, and if the end of this redirect chain 200 is issued, then everything is okay. But there are also cases where you don't want to you don't want to treat the 300s as okay. Mm-hmm. Then you can say only treat 200 okay as okay. So run the help on this. It's really comprehensive, and it might be quite some work for your case to find out the optimal combination of command line options to perfectly handle redirects.
Okay, thank you.
Someone in the back?
Can you just hand the card box to him?
Hi. You talked about authorization improvements. I think you also implemented the basic authentication. Have you implemented someone more, like Kerberos or OAuth?
I have to look up. We have. You can issue cookies. You can issue these bearer tokens. But one moment, I hope still running.
It's okay for now. We can discuss this later on. So you implemented more authorization options.
Yes, we have implemented more authorization options, and we are in progress of listening to customers to do even more. So this is definitely on our roadmap.
Thanks. We have time for one more question, if there is anyone. Nope. Okay. Then thank you, Mattias, for your talk, and give him a big applause.
Thanks.